A very warm welcome to you, my geographer learners. Today we are going to be embarking on an interesting lesson of the day. We are going to be discussing, illustrating, and demonstrating what we call a contour model. But before we can even start with the demonstration of a contour model, I first would like to know if you guys still remember what is a contour line, and also what are the various landforms that you guys have learned about in grade 9. Remember, geographers, this content is a content that you have already covered in your previous class, which is grade 9. Now, let us remind ourselves, guys, let us remember, what are the contour lines? Nice. A contour line are lines found on the topographical map that join places of the same height above sea level. Isn't it right, guys? Good. Now, name 5 landforms that you guys still remember. Okay? Yes. We have a hill, we have a valley, we have a river, we have a plainland, and we have mountains. One might also ask, but say, what is a contour model? Well, guys, a contour model, it is a 3D or 2D design of various landforms represented by contour lines in a topographical map or any map with contour lines. It is basically developed through physical materials, materials that can be able to design a 3D format. Now, geographers, we are about to explore a 3D contour model adapted from a topographical map in an area called Turkey. I have already highlighted the areas of interest with circle bufferings. If we could draw a closer eye on our topographical map, you will notice that there are 2 similar bufferings, and those are our areas of interest. This design of ours was guided by the contour lines of Turkey to form 5 different landforms. Let us please take a closer eye on the topographical map once again. Here is our mountain, and we have our hill right here. We also have a river and a valley. You will note that there is a small feature that represents the dam. On the top of our mountain, we have a trigonometrical station, which is written number 128, and its height is 1762.6 meters from the Earth's surface. If you have noticed, our model also has a dam, a spot height, a trigonometrical station, and an ISO height. It also has 5 different landforms. This includes a hill, like we have saw on the topographical map, a mountain, plainland, a valley, and lastly, a river. They are present on block G3 and J2 on the topographical map. But first, let us shift our focus on our hill. You will notice that the hill has a wider base and its width decreases when it elevates. Same thing applies in the topographical map. Contour lines widens to represent a gentle base of the hill, and the lines are again drawn too close together to indicate elevation
and steepness of the hill. In the case of a mountain, they too have the most widest base represented by very separated contour lines at the outskirts of the close-built contour lines. This illustrates that the mountain has gentle base and a steep mount top. Let us again take note that, guys, we also have a plain land over here. This plain land resembles that plain land on our topographical map, which has no contour line. Bear in mind, geographers, that the numbers linked with the contour lines in our model shows the height of the contour line above the Earth's surface. Here is the number that represents the contour lines. It is also written on our mountain right here, which is written 1500. So it represents that, it means that our mountain, this contour line, the second contour line, our second contour line represents 1500 from the Earth's surface. Lastly, we have a valley and a river in our model. Our valley is represented by the U-shaped contour lines, which bends towards the base of the mountain, while the river is represented by a blue feature flowing away from the steep slope of the mountain and flowing towards the plain land, or the gentle slope rather. I'm sorry about that. I meant to show you this part. Do take note, guys. A river flows from steep slope where contour lines are drawn close together, allowing the body of water to flow towards the gentle slope, where the contour lines seem to be separated from each other. Now, guys, always remember that a flat dimensional map, just like our trigonometrical station map, just like our topographical map, excuse me, it always represents features of landforms which are represented by a contour line over here.
Alright, geographers, in the light of what has been discussed throughout the contour model, I would always want you guys to remember that steep slopes are represented by contour lines which are drawn close together, and gentle slopes are represented by contour lines which are very separated from each other. Always remember that when you open your topographical map, and to be able to assist you to identify certain landforms in your topographical map. And also remember that the valley in our contour model was represented by a U-shaped contour line, and the river flows from the close contour lines towards the separated contour lines, while the mountain and the hill have separated contour lines at the base and very close contour lines at the mount top, or at the top of the hill. That shows at the elevation of the two different landforms. So guys, for your homework, I would like to group you guys in a group of 5 to 6 members per group, and you will have to design a contour model of your own areas and design with certain features, certain landforms that you see in your areas. And I would like you guys to finally present your model in the class. Each group will have a 4 minute per group to present their own model. So guys, please enjoy the homework and yeah, do your best.